Google strives to be a leader in creating standards for artificial intelligence with its open sourcing of TensorFlow, a machine learning API. Although it can be fun to tinker with, can mastering the ins and outs of this software be a true measure of my knowledge of artificial intelligence?
The field of artificial intelligence was founded in 1956 at Dartmouth College in an effort to learn more about the human brain by attempting to recreate it.
Even though machine learning grew from this, it is surprising to find that the field is more closely related to data mining and statistics rather than cognitive and neuroscience.
In order to understand why this is, we must first understand some basic principles of machine learning. A popular definition of machine learning states, a computer program is said to learn from experience E with respect to some class of tasks T and performance measure P if its performance at tasks in T, as measured by P, improves with experience E. In other words, if you feed a program a lot of data and ask it to do something with that data, you can tell that it learned if it gets better at the task. An example of this at work is the classification of handwritten numbers. MNIST is a dataset that represents handwritten numbers in pixels that are given a value based on how dark or light it is. In order for a computer to be able to read these numbers, you must first create a graph or network of operations that the computer can do on all of these numbers, then train it by running all of the data through the network. After it is trained, then you can test it against a set of data to see how accurate it is.
In this example, a program with only one layer of operations is only 91% accurate, but after adding more layers of neural networks, its accuracy jumps to 99.2%. A combination of multiple layers of neural networks is known as deep learning and is the heart of many successful machine learning algorithms. As impressive as that is, it still pales in comparison to how a human learns. In the previous example, it takes thousands of datasets to train a program to tell whether or not this is a 0 or a 1, a task that a 4-year-old can do in less than a minute.
This cartoonish representation of how neurons are networked in our brain is what prompted Douglas Hofstadter, author of what is known as the Bible of AI, to split with the field after the historical defeat of champion chess player Garry Kasparov by IBM's Deep Blue in 1997. He thought that passing off a fancy program as intelligence was ridiculous and wondered why more people didn't share his view.
The reason could be that neuroscience is still far from completely understanding how our brains work, and it would be pretty tough to train something else to do a task that you don't know how to do yourself.
When I wonder about whether or not machine learning will allow us to fulfill the original goals of AI, I am inspired by these photos that were generated after passing in random noise to different programs that were trained to classify different images. These photos not only function as works of art packed with information that would take forever for a human to recreate, but as insights into how a computer thinks and sees the world.
I see future advancements in machine learning not as a detriment to the soul of AI, but as an opportunity to define a new kind of intelligence, just as beautiful as the human